Bill Nye, the man of science, has been thrilling and inspiring us with the latest discoveries about the universe and its countless mysteries for decades. His passion for explaining the wonders of space has sparked curiosity in millions worldwide, guiding us through the final frontier, a vast and seemingly infinite expanse stretching far beyond our planet and into the unknown depths of the cosmos. Today, Bill Nye returns to share insights about the most recent and breathtaking images captured by the James Webb Space Telescope, a marvel of human engineering that offers us an unprecedented glimpse into the universe as it existed over 13 billion years ago, a time so distant that it fundamentally reshapes our understanding of cosmic history, and challenges our very perspective on life itself. The James Webb Space Telescope, often abbreviated as JWST, represents a monumental leap forward in space observation technology. It is not merely an upgrade from its predecessor, the famous Hubble Space Telescope. Rather, it is a revolutionary scientific breakthrough designed to peer deeper into space and further back in time than any telescope before it. Its powerful instruments can capture the faint infrared light emitted by the earliest galaxies and stars, unveiling secrets hidden behind thick clouds of cosmic dust and gas. But what makes the JWST images so extraordinary, so unexpected, and why has Bill Nye described them as fundamentally altering our cosmic narrative? The journey to this point began decades ago. The telescope itself is the result of years of dedicated work by scientists, engineers, and visionaries at NASA, in collaboration with the European Space Agency, ESA, and the Canadian Space Agency, CSA. Launched successfully on Christmas Day 2021, the JWST embarked on a carefully planned deployment sequence. Over the course of the following months, this highly complex machine unfolded its massive sunshield, aligned its mirrors, and activated its instruments with extraordinary precision, culminating in the start of full scientific operations by mid-2022. By the end of June 2022, astronomers began to uncover thousands of previously unseen galaxies, some of which are significantly older and farther away than any galaxies detected before. Some of these distant star systems might have formed as early as 150 million years before the oldest galaxy ever observed by Hubble, pushing the limits of what we thought was possible. JWST's extraordinary sensitivity in the infrared spectrum enables it to detect light from celestial bodies such as exoplanets, stars, and nebulae, revealing information about their chemical composition, temperatures, and movements through space. Bill Nye explains that the data gathered by Webb is already providing an unprecedented level of detail about the atmospheres of planets orbiting distant stars, many light years away from Earth, giving us the ability to analyze their potential for habitability and the presence of life-supporting conditions. Take, for example, one of Hubble's most famous images, the Pillars of Creation, located in the Eagle Nebula. These iconic columns of gas and dust, towering several light-years tall, were captured in visible light by Hubble, showcasing the raw beauty of stellar nurseries. However, while Hubble revealed their magnificent shapes, it could not penetrate deeply enough to observe the birth of stars hidden within. That's where JWST steps in. Using its infrared capabilities, Webb has provided us with an intimate view of these protostars nestled inside the pillars, clusters of gas and dust, each many times larger than our solar system, glowing faintly as they gather material to form new stars. In the JWST images, these infant stars appear as tiny red dots against the blue background of the pillars. According to Bill Nye, these protostars are still in the process of forming and have not yet ignited the fusion of hydrogen that powers mature stars like our Sun. As the protostars accumulate more gas and dust at their centers, their density and temperature increase dramatically. Eventually, when their cores reach a critical density, hydrogen fusion begins, causing the temperature to soar to approximately 2 million degrees Celsius, marking their transformation into fully fledged stars. The colors in the JWST images correspond to different infrared wavelengths, mostly invisible to the human eye, with the blue hues representing the shortest infrared wavelengths detected, and the reds highlighting longer wavelengths emitted by the protostars. This spectrum of colors not only highlights the telescope's powerful infrared vision but also tells the story of star formation in exquisite detail. Moving beyond star birth, JWST is revolutionizing our understanding of exoplanets, planets that orbit stars beyond our solar system. Since the 1990s, over 3,000 exoplanets have been confirmed, yet only a few dozen have ever been directly imaged. Most exoplanets are so distant and faint that scientists rely on indirect detection methods, such as measuring dips in starlight when a planet transits in front of its host star. In September of last year, however, JWST achieved a milestone. It captured the first direct image of an exoplanet, known as HIP 65426b, which was initially discovered in 2017. This gas giant, roughly 12 times the size of Jupiter, orbits its host star at an immense distance. Over 100 times farther than Earth is from the Sun, which makes it more visible to Webb's sensitive instruments. Using a coronagraph to block out the overwhelming light of the central star, combined with advanced filters and cameras, scientists isolated the planet's infrared glow and obtained detailed images. HIP 65426b's unique characteristics, such as its massive size and distance from its star, made it easier to observe and analyze. Its direct imaging opens up new pathways to studying exoplanet atmospheres, temperatures, and compositions. Another fascinating discovery comes from observations of the Ghost Galaxy, also known as M74. Though faint and hard to see with the naked eye, JWST's infrared cameras reveal remarkable features of this spiral galaxy. The telescope's images show delicate, fiber-like structures of heat-emitting dust and gas emanating from a bright, electric blue core, marking regions of intense star formation along the spiral arms. Combining data from both Hubble and Webb, researchers at the European Space Agency produced a stunning composite image of M74, merging optical and infrared views. This project is part of PHANGS, an international effort to study 19 nearby galaxies in multiple wavelengths. Webb's sharp infrared observations enable astronomers to pinpoint the locations of star-forming regions and accurately determine the masses and ages of star clusters within these galaxies. In a separate observation, JWST captured an extraordinary image of the massive star Wolf-Rayet 140, WR140, in July of last year. While diffraction spikes, bright lines radiating from stars, are common in telescope images, scientists were captivated by a unique pattern of wavy, concentric rings with a slightly square shape surrounding WR140. These rings are not imaging artifacts but physical features linked to the nature of Wolf-Rayet stars, enormous, luminous stars in the late stages of their lives, having shed much of their hydrogen. In the case of WR140, interactions with a nearby companion star create the peculiar shapes of the rings, providing valuable clues about stellar evolution and mass loss in dying stars. The James Webb Telescope's capabilities extend to studying the earliest galaxies ever observed. In December of last year, researchers announced the detection of 4 galaxies dating back 13.4 billion years, when the universe was only 350 million years old, a mere 2% of its current age. These galaxies were identified through a major survey using JWST's near-infrared spectrograph, NIR spec. By measuring the galaxy's redshift, the stretching of light caused by the universe's expansion, scientists were able to confirm their extraordinary age and distance. The highest redshift recorded was 13.2, a record-breaking figure that confirms JWST's ability to probe deeper into cosmic history than ever before. Before JWST, such distant galaxies were beyond our observational reach. Now, astronomers can not only locate these remote systems but verify their distances and ages spectroscopically with remarkable accuracy, opening new windows into the universe's infancy and the formation of the first stars and galaxies. JUIC's exploration also includes detailed studies of exoplanet atmospheres. One of its most intensive investigations focused on WASP-39b, a Saturn-sized gas giant located 700 light-years from Earth in the constellation Virgo. WASP-39b orbits perilously close to its star, about 8 times closer than Mercury is to the Sun, causing its atmosphere to heat and boil. Using 2 of Webb's powerful spectrographs, scientists detected various molecules in the planet's atmosphere, including sulfur dioxide, carbon dioxide, and silicates. These findings help researchers understand planetary formation, atmospheric chemistry, and the potential for diverse planetary environments across the galaxy. Bill Nye believes that these groundbreaking discoveries mark a new era in astronomy and planetary science. Every image captured, every spectral reading taken, brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? If this journey through space and time has sparked your curiosity, share your thoughts in the comments below. Don't forget to like this video and subscribe to our channel to keep exploring the wonders of the cosmos with us. Until next time, keep looking up.